Just a mic check. Yeah, we're good. All right, good afternoon, and thanks for coming. My name's Thomas Dinsmore. I'm a freelance consultant and author. I'll be talking about, well, this is the title, Spark and the Future of Advanced Analytics. Now, that's a hugely broad topic, so I'm going to have to narrow it a little bit. Now, typically in conferences like this, most of the presentations will either be, fairly hardcore, here's some Java code, or they'll be sort of rah-rah. I'm going to throw a bit of a wet blanket on things to start off by talking about, here are some reasons that you're going to hear from people who are analysts out in the, the broader corporate world of business analytics. People are going to ask, do we really need to have a distributed platform for machine learning? And you'll hear roughly 5 arguments against using a distributed platform, which, again, may be odd to hear at a Spark conference, but bear with me. So the first argument goes like this. Okay, we get big data. We totally understand that our organization has to handle petabytes of data, and we need all the infrastructure to handle that. But by the way, the analysis I need to do, I can do on a laptop. And the typical analytics team that you'll see in companies like Boston Consulting Group or in Bank of America and so forth, you'll see a pyramid like this. In other words, if you look over the flow of projects that come in, the majority of the projects and the analytic requests can be handled with a relatively small data set, small snippet of data, but you do have some projects that do have, and let's just say a terabyte of data as a cutoff for analytics, which of course is much different from, terabyte's nothing in the big data world, but in the analytics world, it's actually a pretty big data set. So a second argument you'll hear from statisticians mostly, you'll hear there's this perception that we actually don't need a lot of data because when we build a predictive model, measuring the accuracy of the model with the AUC against the validation data set, we actually find that after a certain level of data, in this case 100,000 records, the accuracy doesn't improve. And you hear this argument quite a lot. The other argument you hear is that all of the tools that people are accustomed to using, legacy SAS, IBM, RapidMiner, basic Python, scikit-learn, and R, all of these are built, they were optimized originally for single machine computing, right? And so something like legacy SAS, for example, has hundreds of procs. Most of those procs aren't still even single-threaded. Some of them are multi-threaded for cores on a single machine, but distributed computing is way out. And since this is what people are familiar with and what they're accustomed to using, a distributed machine learning platform is like, well, you're asking me to do something different. On top of that, you have this basic fact that machines themselves, single machines, are getting much more powerful. And so if somebody says, I can do the analysis I need to do on a laptop, they're not lying. Just on a lark, I ran a model on a 1 billion row data set on a desktop. Again, the machines are getting increasingly powerful, especially with things like GPU chips. And for a little over $20,000, you can get a machine with a terabyte of RAM and 64 cores. That's a screamer, right? So it's, again, from the basic perspective of the analyst, the actuary, the credit analyst, and so forth, it's like, why do I need this distributed computing stuff? And again, the last argument is basically, it's hard. It's something new. I'm going to have to need to learn new tools from the standpoint of, say, software companies. We're going to have to rebuild our software. And by the way, that rebuild is non-trivial, right? So a company like SAS, with all its resources, has 300 procs in its legacy products, and it has about 30 in its distributed product, because everything has to be rebuilt unless the task is embarrassingly parallel. So let's talk about why you do need a distributed machine learning platform, because it's useful to know why, what to say to people when they say, well, we don't need this stuff. So the first thing is that you may be working with, just a small data set, but you're going to have to find that small data set in a huge swamp of data. In other words, There's a process that involves, maybe your data set fits in a laptop, but how did you get it there? Right? Your process, you might think of your process like this: data wrangling, feature engineering, model training, and prediction. But in fact, it's going to look something like this. You're going to start in that swamp of enterprise data somewhere and do your data wrangling, then your feature engineering, model training, and if you're deploying a model, somehow you're going to have to get it back into that swamp. Now, it'd be great if you could do the whole thing in the database, but the point being is there's no escaping, right? The people who are saying they can do all of their analysis on a laptop are leaving out the part that involved getting the data there in the first place. The next reason, why we need a distributed platform is the basic problem that data movement is expensive. It's in some cases impossible, right? So if your data is curated, like in the case of clinical trials, you may not be permitted to move your data out of Hadoop or out of the data store, wherever the data's left. It also might be from a standpoint of timing, scheduling. With a very, very large data set, it could take days to move the data over a corporate network, right? Timing, cost, policy, security issues, and so forth. There's a basic rule in that people think of in terms of highways, is that every highway, when you build it, there's no cars on it. It's really fast, but sooner or later it fills up. Well, it's a basic rule of analytics that no matter how big your box is, right, there is an analysis problem that will max out that box or exceed the capability of that box. The model accuracy problem also, and the reason you hear it from statisticians, is that while it's true with linear models and traditional statistical models that you'll get a max out of the AUC at a certain level, it's not true for machine learning models. So in this case, we're comparing a linear model with random forest. With random forest continues to learn as you add more data, and by the way, that's the AUC in a validation data set, so it doesn't represent overfitting. And finally, the whole, in Boston it snows several times a year. Well, you only use the snowplow a couple times a year, but you still need the snowplow when you need it, right? Similarly, if we go back to that pyramid, if you're an analytics team, maybe you only have 20% of your projects that require that you work with large data sets. But the fact is, when you need to work with large data sets, you need to work with large data sets. Let's take a simple example. Anyone hear of Microsoft's new deep learning kit that they just open sourced? Computational network toolkit. Anyone hear of TensorFlow? All right. Okay, another deep learning toolkit. Okay, so computational can work over multiple cores and it is distributed, whereas TensorFlow in the version that Google outsourced, it cannot be distributed. So if you're running on a box with a single GPU, well, not that much difference. CNTK is a little faster. If you're running on a machine with 4 GPUs, okay, CNTK makes use of those 4 GPUs better than TensorFlow. And if you say, well, I need even more speed, okay, I'm going to set up a cluster. Well, can't do that with TensorFlow. Now, Google just announced a service, and there's speculation that Google's going to come out with a distributed version of TensorFlow, since the scuttlebutt is that Google uses a distributed TensorFlow inside Google. And they just made an announcement this morning, but so far as I can tell, it's still not distributed. Point being that, again, at some point, you're going to need to be able to distribute your analytics. And so if you're stuck in a single box, single threaded paradigm, at some point you're going to max out. So I think most people in the room would agree that the future of analytics is distributed. And why? It's because your data sources and targets are distributed. You may only need a snippet of data, but you still have to retrieve that snippet from something. Second, data movement is expensive. Data requirements are expanding all the time. In other words, the average data set that analysts report in polls and surveys is growing every year. The machine learning algorithms that are available to us can use more data than the traditional methods. And finally, when you need capability, you'd better have it. So what does all that mean? Okay, so several years ago, a number of vendors, analytics vendors, figured out that basically with the growth of Hadoop and other distributed models, that distributed computing would be a good thing. And so these are just 5. There are probably others, but SAS, Revolution Analytics, H2O, Alpine, and Skytree all began to develop some kind of a distributed machine learning capability. Now, one of the characteristics of that early development is that everyone developed their own distributed framework. SAS has its own proprietary distributed in-memory framework. Revolution built its own. Skytree built its own. H2O its own. Alpine leverages a massively parallel database in its original version anyway. So, but here's the problem with that. Having everyone use their own distributed framework is like having everyone use their own file system. And the reality about advanced analytics and the way analysts actually work in corporations is nobody relies on a single vendor. All right? Certainly not the best machine learning people, not the best data scientists. Nobody is willing to say that any one vendor is best in everything. They all like to mix and match, which means that ultimately what you want to do is you want to have a common distribution framework that everybody shares. A little bit idealistic in the case of SAS. I don't think they're going to want to get along on the same pony with everybody else. But as customers, as enterprise architects, this should be the goal of adopting a common framework and demanding that vendors work to it. And that, of course, is Spark. Now, why is it Spark? Now, the thing is, about 10 months ago, I wrote a blog post because I've seen a bunch of people who were basically snarking about Spark and saying it was overhyped and saying that it wasn't enterprise ready. My feeling about that, and look, Spark is certainly relatively new and all software has bugs. I'm not suggesting Spark's perfect. I don't think the Spark team would say it's perfect. But the plain fact is, find better, right? In other words, if you agree with this basic notion that we need a common distribution framework, if you don't like Spark, show me something that's better. So, now what does all this mean from the perspective of the actual analyst? Some person that works, the actuary, the credit analyst, the financial analyst, and so forth. Well, again, go back to the pyramid. These folks may use Spark or a Spark-based distributed machine learning algorithm sometimes, but most of the time they're working with small data. So it's really, really important that we find ways to ensure that general purpose tools, the kinds of tools that these folks are using every day for their everyday work, have the ability to access a distributed machine learning capability when needed, right? But are otherwise able to do their everyday work. So ultimately, we'd like the capability, if we're going to push all these processes, right, into a database and into Spark, we'd ultimately like to have something on the front end that's going to make it possible for, that average credit analyst, that average fraud analyst to use it and still mix and match the Spark processes with everything else they want to do. The little report they need to do for the CEO or the response analysis they need to do for marketing. So now, Spark itself has great APIs, right? But there are not that many actuaries or financial analysts or marketing analysts who are working with Java, and not very many that are working with Scala. Now, there's more that are learning Python, and Python is certainly growing rapidly. There are quite a few that use R. Now, one of the challenges for the Spark team, and it's not a criticism, it's just a statement of fact, at present, the R API isn't as well developed as the Scala and the Java and the Python APIs. So for the R user doesn't have quite the same options as a Java and Scala and Python user. So one solution is learn Python, but also there are a couple of other things. One is that we need sort of more people contributing to the Spark R API. But there are also a couple of other things going on. So Spark R is actively under development. Also, IBM System ML, Fred Rice from IBM will be presenting in the next half hour up in the main hall on System ML. Strongly recommended. It's actually, I was initially skeptical about it, but they actually are onto something. That's a very, very cool product, and it has R-like and Python-like APIs pushing down into Spark and MapReduce. There's also an emerging product that's coming out of HP Labs in Cambridge, the ex-Vertica people, the DDR project, which is creating a sort of a generalized R front end that can point to Spark and other backends. For the ordinary business analyst, though, I think most people feel that ultimately we're going to be looking at commercial tools of various kinds. In other words, even R is probably more programming than a lot of corporate analysts want to do. So just looking at this is the Gartner Magic Quadrant. Now again, they just updated it, and after I submitted the slides, so there have been a few minor changes to the Gartner Magic Quadrant, but just looking at some of the leading vendors, first of all of the ones that Gartner considers visionary, that is over on the right-hand side, all of them, without exception, are building in some capability to push processing down into Spark. And when I say push down, I mean the user still sees a familiar graphical front end, but between the user and Spark, something's translating the user's request into Spark commands and submitting them through one of the APIs. SAS, surprisingly, recently shipped a product that supports Spark Pushdown. It's an ETL, essentially an ETL product for Hadoop. And then IBM has a product that was mentioned in the keynote this morning called Analytics Server, which serves as a broker between SPSS and a Hadoop distribution. So it will push down SPSS modeler request down into either MapReduce or Spark, depending on if Spark is running, it'll push it to Spark. If Spark is not running, it'll push it to MapReduce. A couple others, and just let me make caveat, this isn't a sponsored presentation. People don't pay to get into this. I just think these vendors are on the right track. So first of all, RapidMiner is, anyone here of RapidMiner? Yeah, open source, mixed open source commercial project originally in Germany, moved to the United States a couple years ago. They make it's not a bad user interface, a fairly powerful tool, about 1,500 operators. RapidMiner has created a component, they call it Redupe, and it pushes most of their functions down to Spark so that you're able to, from your RapidMiner front end, perform a number of operations, and it will push it down, perform the work in Spark, return the result set to you. The coding up and passing of the work through the API is transparent to the user. Can also embed custom PySpark and Spark R scripts. By the way, I haven't personally tested these either, right? So for all I know, these folks are making claims and they actually stink, but so caveat emptor. But again, the first thing you have to do is make a claim, right? So NIME is a Swiss-based open source project, again, mixed commercial open source. Not a lot of US presence, rated by Gartner as a leader on the strength of their offering. Visually, it's, I think, a little bit nicer than RapidMiner. NIME has what they call an extension. Their basic product, their visual-based product is pure open source, but the extension that enables users to push operations into Spark is a commercially licensed version. And that is essentially a graphical interface to Spark MLlib. They have separate extensions that push into Hive and Impala, all promising, and then have the capability to score. You can take PMML models, pass them to KNIME, and execute a scoring run in Spark. A company that's here today, H2O.ai, is more oriented towards an expert user in the sense that a lot of their users are working with their Java or their Scala or their Python APIs. And H2O is one of the first companies to contribute a Spark package they created. They still have their own distributed framework, which is highly respected by people in the machine learning community for speed and accuracy. However, they have also created a Spark package called Sparkling Water. I believe tomorrow there's a presentation on Sparkling Water. And Sparkling Water enables you to work with H2O, but point it to Spark RDDs or data frames, so that you can essentially do your data wrangling with Spark, but then use H2O to do your actual machine learning. And it's a great way to get, there is some overlap in terms of the libraries between H2O and MLlib. But there are also some unique things. So for example, there is a deep learning capability within H2O that we don't have in MLlib. If anyone was here for Mike Galtieri's presentation, he talked about automating machine learning. Company called DataRobot, how they use Spark to automate machine learning. So essentially, DataRobot will take a data set and profile it and remove duplicate values and remove redundant values and so forth. Remove variables that are, for example, missing completely. In other words, there's some basic simple rules, but then they generate an experimental plan for feature engineering and model training. And because of the differences between model techniques, right, you actually need different feature engineering for different models. You can't just dump all the models into a loop. And then they create a large number of experiments. The actual experiments themselves run in R or XGBoost or Python, H2O, or Spark. And then they create a leaderboard to track, track the accuracy of the different models that they're developing with the different techniques. And then they'll select a model. Now, you can either just let the system default to whatever model has the lowest AUC or whatever model metric you chose, or you can override DataRobot and choose the model that whatever you want. But then it uses Spark. It will then push down whatever model you select as your final model. It uses Spark to push that back into Hadoop, either as a batch or in a real-time scoring process. I think DataRobot's here as well. So let's summarize. Yeah, distributed machine learning is necessary. There's no way around it. I mean, again, the volume of data is such, and the fact that we're pulling from the data means that analysts need to have tools for distributed machine learning, and that framework needs to be a generalized framework. In other words, it doesn't do us any good if every single tool we have has its own distribution framework. Right now, Spark is the only game in town that offers an open source distributed framework. And again, I'm not saying it will always be that way, and I'm not saying Spark is perfect, but I would defy anybody who agrees with the first 2 points that there's any alternative to Spark. And finally, the race is on among commercial vendors to deliver real push-down Spark integration that will enable ordinary business users to benefit from the machine learning capabilities of Spark. And I get a chance to mention that I have a book coming this year called Disruptive Analytics, but I won't spend time plugging it. I do publish something called the Big Analytics blog under my name there. Feel free to come by and read and comment. Are there any questions? And thank you.
Yeah, hi. I have one question about the toolboxes. Typically, if you look at big analytical engines like MATLAB or R, they have the toolboxes like financial derivatives or econometrics and so on and so forth. Do you think that that ecosystem is going to be appearing in Spark in the near future also?
I'll speak specifically to MATLAB. MATLAB hasn't shown a great deal of interest in big data in general, right? Now, they do have some capabilities, but I'll make a general statement, right? As software vendors go, MATLAB seems to feel that big data is not a pressing problem for their users. And I think for a lot of their users, that's probably correct. Now, I'm not saying that they will never, but they're not, I haven't seen anything from MATLAB that suggests, I haven't seen any kind of Spark pushdown or anything like that. But I'll have to be honest, I haven't looked at MATLAB in 6 months, and this business changes so quickly that it's possible that they just announced something, right? What were some of the other frameworks you mentioned?
Yeah, there are lots of libraries that, even R has the financial packages and all those things. So
Yeah.
I was wondering whether beyond Spark, which has got the machine learning as a package, there's
Right.
also other statistical libraries that would come on top of the data that's sitting in Spark.
It's fair to say that just about any package you can name that's more than a few years old is probably going to be challenging to distribute, right? In other words, R, for example. There are tools in R that will enable you to set up a distributed environment. They're a science project to work with, right? And so even for someone like Revolution Analytics that acquired by Microsoft that had a commercially distributed product, they weren't actually distributing R. They created a whole new set of algorithms and put an R front end on those algorithms. So far as MATLAB's concerned, hard to say. A lot of the capabilities that are within MATLAB are available elsewhere. And I think that MATLAB seems more interested in things like GPU chips. Right? They're folks that seem to, they approach the problem more in terms of let's just get the biggest box we can and most powerful box we can. They're not really interested in the distributed. Once you go into distributed computing, you're looking at something entirely different. And if the algorithm isn't embarrassingly parallel, you basically have to rewrite it. For something like k-means or for logistic regression, something like that, you cannot take a single-threaded, single machine algorithm and just distribute it willy-nilly, right? It actually takes serious work. That's why for example, if you look at the number of algorithms in Spark and you compare it to the number of algorithms in R, there's 5,000 packages in R. There's 15, 20 algorithms in MLlib. It's a lot harder to do. Does that answer your question?
Yes, it did. Thank you.
All right.
Any other questions?
Like analytics in healthcare, for example, there are custom purpose-driven analytics platforms. How do you see that evolving?
Okay, so the question is for healthcare specific or just industry specific?
Industry specific.
All right, so
niche.
specifically industry solutions, whatever industry they are, typically involve a couple things. A core of analytical tools, which are typically similar across the different industries, plus intellectual property, data models, pre-built reports, pre-built analytics, right? Plus different front ends, right? Different ways of visualizing. And in some cases, there are different analytics. So that, for example, if you're talking about financial markets, there's a very specific set of algorithms and analytics that have developed almost historically, right? So in terms of how they're going to evolve, I think everyone that feels like that has to deal with big data is going to have to address the scale-out architecture. And anyone that's working in, using these data lakes and data warehouses that organizations are going, they're at minimum going to have to figure out ways to use distributed analytics for things like selection, summarizing, feature extraction and things like that, right? The industry solutions you put on top of the tooling. First, you have to get the tooling right. Then you can put the industry solutions on top of that. So that, for example, SAS first shipped a product, a general purpose distributed analytics platform. Now it's in the process of developing industry solutions that they sell on top of that. Does that answer your question?
Yes, sir. Quick follow-up question. So do you see other vendors coming in and filling that gap, or do you see the brands and the companies taking the bare bone and building those up?
If you look through Crunchbase, if you look at companies that are in the analytics space, you'll notice that the ones that are getting traction are the ones that have some kind of a solution, right? Because tools themselves are becoming commoditized. I mean, it's kind of hard to compete with open source, right? Right. So the only way you're going to compete with either open source or with big companies like SAS and IBM with deep pockets is to do something that's uniquely different. And usually the only way you can do it is say, I'm not offering a generic tool for logistic regression. I'm giving you something that helps you figure out when you should discharge your patients and not get your Medicaid reimbursements cut. Something like that. Does that make sense? All right.
Thank you, Thomas. At this point, we'd like to